Do I have working mic now? I just realized that I've been silent for a while. That was real smart. Okay, so what I was saying before that was real brilliant to me. Um, yeah, that was a genius moment. That is certified streamer moment. Okay, so what I was saying was that I let Bash build in in previous overnight, and it successfully built Bash. I probably won't be able to log in as root. I remember NetBSD has precautions. So can I do an add user and commander user add? Oh, you are going to complain about that. User add and commander. Like, I don't really care about this system, but password and commander. I'm actually feeling better than I did yesterday. And yesterday, it helps a lot when I just work on things I want to do. And this is, I kept thinking about working more on this yesterday, which I take to be kind of a good sign. Okay, so do we have working telnet? That's interesting. Okay. So if that is actually working, where are we? We're here. So let's copy bash to user local bin. All right, and then let me grab NeoFetch. Wow, that is excruciatingly slow and painful. Okay, so NeoFetch. We want to grab the raw. Yeah, that's about... Alright, so let's grab NeoFetch while we can. Do we have Karl? We have neither. I think it's called HTTPS. Yeah, there we go. All right, so all right, let's take a look back here. I've been, like I said, the last few months has been really bad for me. I'm trying to kind of get past it now. All right, so this is NeoFetch running on the host system, or well, the AMD 64 NetBSD thing. All right, so we can telnet into this, and let's see here. User local bin bash NeoFetch. I just use it because I know high fetch is a thing. I should probably grab high fetch. Should like get there. That's right. I'll grab high fetch. Oh my god, look how slow it is. That is impressively slow. Right. Now, the reason I don't use high fetch is it requires, I just remember it requires Python. They have an updated one, Wow, chat, look how slow this is running. Yeah, well, if I used fast fetch, it would be fast. Has it actually crashed, or is it still going? Uh, I didn't see your comment on the previous video. Is there a Linux Next Step port? I looked around. I didn't see any version of. Let's see, I type NeXTstation. Oh, interesting. I just found a repo that is actually a little bit useful. I don't know if this crashed or... Yeah, I think it crashed. That is interesting. Why did that crash? Like, even running clear takes a while. Really takes a while. Or just completely hangs the system. But I just found a bare metal... So this is what I just found looking. I'm going to have to find that comment. Yeah, this is actually kind of useful. So this is actually doing what I kind of want to do myself. Was basically stripping down... I still want to do this myself instead of using this code, but... This is actually handy, and I'm going to save that. I didn't know of an existing NeXTstation next port of Linux. I think I'm still just going to do my own. Let me see if I can find your comment. Let me pull up the studio in our window. Because I'm only going to port the Linux kernel as a learning experience. Let's see here. YouTube has some legal stuff I need to look at. Frig. Okay. Community. Yeah, I don't see any posts. Looking at the other thing. All right. So what I wanted to do today is I pulled out the source code to the NetBSD bootloader. And I want to get this building independent of the NetBSD build system, and then I want to strip this down to a bare minimum. If we're going to... I spent some time last night after I did my classwork looking at how the Motorola 68000 code actually starts. I actually looked at the code to Emil, which is the... classic Mac Linux bootloader. It's actually really simple. The kernel sends the bootloader sends a boot structure to for the kernel, which basically says what machine it's running on, and it sticks it directly below the kernel's load address in memory, so it can be read by head.s. What really kind of surprised me is how fucking nicer this is than the ARM tree. Like the ARM ARM still cannot like consistently get one kernel that runs on everything. It's gotten a lot better because now we've got flat device tree, but it still has a lot of limits. Meanwhile, the Motorola 68000 port is one binary for literally all of them, which, yeah, I mean, it's not that many machines, but they're completely different. Like, you have one binary that can run on classic Mac, Atari, Amiga, HP 300, and it just runs as one thing. So you've been working on bare metal. Yeah, like it doesn't look that bad if I actually want to just get. Right now my goal is I just want to crash in the kernel. Like, I don't know if I'll take it all the way to a functional port. Okay, I need to start with doing something. So we do have this make file. Actually, I kind of want to open this folder up and make some changes. File Explorer. Yeah, let's go up a level. Let's delete this make file because I don't actually need this. And then we take all this and we move it up one level. And then the object folder can go away. Okay, fine. Yeah, I guess it doesn't go away. All right. And then let's rename this to makefile BSD, because this is in the BSD format. So, okay, let's start with making a new makefile, which is in a new makefile format. And we take... So the way this works is kind of really hacky. It basically puts an A out header on the boot binary and then makes that work, which is a solution. Yeah, because it obj copies out a binary raw and then it sticks the header on, which isn't a good solution, but it is a solution. I gotta remember how you actually make a fucking makefile. It's been so long. Like, I'm really trying to break off a lot of rust here. So, yeah. Let's start with our new one. And that's going to be boot. And then we kind of just want to list all the source files for it. So we have this list of source files. It's not everything because I need the other stuff from the standalone directory. Yeah, so this is all the stuff that makes the boot program. And then prog. So what else are we actually doing? Does this not define the objects? No, it doesn't. It's The BSD make files use a lot of deep macro magic to basically do what it does. So I think I just need to change these all to /O because then I could do a find and replace faster. Alright. So the next thing we want to do is we want to take our tool chain. Tool dir Linux bin. Okay, alright, that gives me my tool chain. So let's go to the stand folder, make file. Okay, that's a starting point. Current directory. Definitely not the most cleanest thing in the world, but let's definitely get things started. Get rid of that. Okay, so that... Did that make a .o file? Oh no, it's missing an include. So now we gotta go hunt down the includes. Like I said, I just want to make this as basically a minimum viable. Actually, I have Hell Classic energy drinks, which is currently what's keeping me up and functional. I'm sitting cross-legged on my chair because it's the most comfortable position I can be in. All right. So I think we gotta go to include. It might be an Arch NeXT4. Let's see here. Include. What file are we looking for? Machine ASM. Let's take a look at you with VS Code. Can we just... What do we need from this file? Okay, yep, that looks like a completely self-contained file, so let's just grab that. And we are... Okay. Machine ASM should be here. Oh, I probably have to add it to the include path. Let's see here. C flags includes okay. Okay, so there is this profile. Oh yeah, so we need to add some more defines. Yeah, it needs a bunch of these because we need elf, pick, entry. Yeah, that makes perfect sense. All right. So this is basically what we want. Do we need more than that? Support DHCP standalone and secure. Oh, maybe it helps if I actually save the file. Okay, that actually that did build. So we got srt0.o, and it's in the right format. The goal here is I want to be able to have a copy of the bootloader that I can easily screw around with that's independent. I want to learn about booting the hardware, which I can do this, and I want to strip this down to bare metal. So I basically just have an example hello world program, and then I want to make sure I can boot that with the bootloader, because we're going to need the bootloader to load up the rest of the kernel, and this feels like the easiest way to do it. All right, so if we type make boot, yeah, okay. So now it wants a bunch of other files that I have to go hunt down and find. A bunch of stuff from libsa, which I did copy, but I'm assuming is not in the place it wants to see it. All right, so what file was it unhappy with? Yeah, so it's in boot.c. So let's do some editing. Alright, so I need to find the sys files. Like I said, I want to basically isolate this out. This is also going to be a test bench for some other things, so I gotta figure out where. Let's see, go down to sys. Okay, so what do we need from here? Param and reboot. Okay. How much unhappy? Okay, that actually means very unhappy. This was kind of my concern. It's like I want to basically be able to have a minimal environment, and I'd rather figure this one out on my own because the experience is going to be helpful, or at least so I think. All right, I need null. I need int types. Yeah, like I'm not 100% sure this is the best way to go about this, but it's an idea, and I feel like it's the right idea, is to at least go with what I can think of going with. All right. Sys limits and signal. Alright, that should be a bunch more files. It should be less unhappy. Yeah, no, but the headers are basically all intermixed with each other. Is there a better way to do this? I'm just thinking about it right now. I could just point the header paths to the NetBSD source code, and that might be a less terrible solution. Yeah, why don't we go with the less terrible solution, and we'll work on fixing the headers later. Actually, I like that idea a lot better. So instead of doing it like this, these just go bye-bye. And then let's edit the include paths. All right, so let's undo that. So from here, it would be NetBSD source sys. And that should actually be in the right place. So I just need to add that as a make directory. So NetBSD source sys, like that. Okay, so now it's less unhappy. So I think what it's looking for is the Arch folder. Let's see here, Arch. Assuming it's looking for the Motorola 68000 folder. Include. Trying to figure out where machine gets linked to, because this is where it pops out in the source code. I think on the installed system it must end up somewhere else. So I think the easiest way to solve this is with a link. NetBSD source sys Arch M63 include machine. All right. That I don't. Yeah. Well, I mean, no, that can't possibly be right. Yeah, okay, so the headers get... Okay, so you know what the right solution... Well, I'm not going to say it's the right solution, but until I get much further along with this, the cheaty solution is we do this. Because that'll get the include folders from the main operating system, which is what it looks like it wants. Missing separator... Ow. I am in a fair bit of pain. Oh, wrong folder. That's why it was complaining. Okay, that actually went a step in the right direction because that's a lot of the errors just magically cleared up. So I think I just need to add NetBSD source sys because that's where the root of it is. Because none of these definitions I should have to change. Those, though, are a little bit... Okay, so I need -s NetBSD source sys arch, and I think I need NetBSD source sys arch M64K. Okay, that only had one file that it couldn't find. Sys arch. Oh, you need next, not yeah, you need NeXT64. Okay. Source sys arch next. Oh, you need next include. That makes sense. Yeah, let's get the code isolated first, and then I can deal with making the headers less horrible. Oh, that's how you want it. Okay, hold on. Oh, you're going to be a pain about this, because you want it in a different folder. Okay, fine. NetBSD source sys arch next include load file. Okay, that built the first file. Yeah, I got a .o file out of that. So that's actually progress. That's actually really good progress. Okay, so it wants libsa, which I copied to this folder. Yeah, I did, so... Oh, okay, cool. That built all the files except for vers.s. But, that's an auto-generated file, so let me just see if I can find it. Vers.c. Yeah, we can just copy that. You also need that. Okay, so that did build the boot thingamajigger. And how can I make this load as a make file? That's not what I'm looking for. Okay, let's see, make file. Let's see what chat's saying. Right now I'm trying to isolate out the bootloader code into its own independent unit. Yeah, so this, yeah, that all gets built. And then this is what it basically tries to run to do the final thingamajig. All right, so let me grab that. And let's see if we can convince it to do anything. All right, we need to tell it to use I am worried that that is not going to work with Gawk, but we'll try it. Alright, and then prog is boot. -N not found. Okay. Is it possible you are actually GCC in disguise? You might be. Oh, well, that would actually do it. Okay, so now it wants start. Oh, you know, I just noticed that here it makes the include links. Okay, so that is actually expected. So where does start come from? Yeah, I'm currently, like I said, I'm trying to basically isolate this down to its own self-contained example. So the only start it finds is that, which is not helpful. Okay. I think start is the entry point, now that I think about it. Let me look at the linker. Yes, start should be the entry point. Okay, so is it telling me, I think it's telling me that it's not seeing the symbol. Yeah, here it is. AS entry. Okay, so M64. I need NM. Are you not defining the symbol? No, you are defining the symbol. It's there. Start. Although it's undefined. which kind of tells me my macros are effed up. Yeah, that tells me my macros are screwed up. Oh, no, it's trap that's undefined. No such file directory. Let me just take out this, and let me just see what comes out. Invalid hex number. Okay, so now I do need that. Yeah, that's expected because it's just the way NetBSD builds their compiler. Because like I said, I want to basically build this down. I want to get this, and then I want to cut this down even further to basically just the code needed to do Hello World, so I have a test bench to work from. Which is going to be important because I'm going to have to test that the Motorola 68K Linux toolchain builds an ELF binary that the NetBSD bootloader can. So this has multiple utility steps. I just kind of need to figure it out. Maybe I'm building it wrong, so let me look at the net. Let me look at here. Let me find SRT0 source. There we go. Motorola NM sys arch NeXT64 stand boot object SRT0. No, that is the same. That is absolutely the same. Yeah, that's completely and totally the same. Oh, hold on. I just realized there's this variable here, relocks. That needs to be here. Okay, there we go. That tried to link, which is actually a good thing. So now I think I just need the files in... wow, this is a flipping mess. Yeah, I think I just need these files. These might need different C flags, but yeah, these are basically what I needed. Yeah, IO routines. So I think the goal is to build this. Load file, net. God, I'm not awake. It found a new home in Portland, so I don't have it anymore, which is kind of unfortunate, but do I want to try and build this? Like, I'm sort of procrastinating because fixing this make file really just does not feel like fun. I still think it's a good idea that I actually have this, like, sorted, so yeah. Frig, I guess I just need to do it. I'm just gonna add it to this make file. It just makes my life a little easier. libsa dev.o. Because otherwise I have to try and remember how to do like recursive make files or something of that matter. It's half of it's trying to get through like the brain fog. I am worried that these need to be built with different flags. I mean, it should be fine. Okay, I need to do a change all occurrences. No, that's not what I'm looking for. .c to .o. Just because I don't want to have to deal with all the fucking macros. Okay. And now I add libsa colon. It's not all the files, but I just want to try booting. Okay. Yeah, okay, cool. That basically just worked, which was kind of nice. apparently these files are not here. Oh, they must be in like a generic libsa somewhere. The fuck? Oh no, it does copy them from there, because look at the path. Okay, so that does actually track. Alright, so where are the other ones from this folder? The memcopy, memset, memmove. Okay, that definitely is moving in the right direction. Okay, now it's just missing a bunch of basically all these. Null of S. Where's that one? Okay. Did I not get B0? I guess I didn't. Oh yeah, no, I wouldn't have. So BSA B0.0, and what was the other one that it was? Bcopy. Okay, now we're starting to get somewhere. It's starting to get somewhere. I'm gonna be right back. Alright, I'm back. Oh. Yeah, I mean, it doesn't look too much worse. I just gotta basically get through all this. I gotta track down all the files, blah, 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 blah. So yeah, let's get all the IO stuff. Nope, I got that line already, so it would be this line would be the next one. All right, we are getting there. So I think I need all the networking code. I'm actually almost certain I do. Yeah. All right, and I'll just do all the file systems in one go. All right, let's see how much more builds. Oh, did I forget a separator? I did. No rule for RPCO. Okay, that's got to be another one from... I shouldn't have to adjust this. I already have it in there. I'm telling myself I'm doing this for a reason. I know that that reason exists. Okay. Yeah, okay, so with each one, the number of functions it's missing is definitely going down. Alright, where are we in the chat? I can't decide if this is more or less work than I expected it to be. Ripping stuff out of a build system is always like hell. I've had to do this a few times in my life, and I always really hate it. Okay, we are... Is that all the files? I guess so. So now I need to figure out the ones I'm missing, or otherwise... So path.o, it looks like it will reuse some object files. No, path.c. So what is it actually missing? So it's missing try bootp, which are missing references to Sterling, bswap. Okay, so libc, or hold on, find... Okay, it's treating bswap as a function. My guess is my headers are not correct. In fact, I'm fairly certain they're not. Alright, how do I fix this? Credentials. See directory, miss CCP flags. Let me see if I'm missing anything else. Alright, some of this code looks like I don't actually need. So let's get rid of the stuff I don't. I don't need... Yeah, that's bizarre that that needs to be there. I know that this bootloader is made out of a lot of copy and pasted bits, and then it's basically define flags that hold it all together. Alright, so that's one thing I know I'm missing is devnet. Which is where? Not included here, interestingly. DevNet. Yeah, devnet.c. You know, let me just give it a stir copy and stir number function I can use just to get rid of more of these errors. If I write these correctly. Okay, so that got rid of a lot of those messages. Let me get rid of check password unless I actually need it. Yeah, let's just get rid of the ones that I don't actually seem to need. We're not going to be booting from hard drive, so I think all of these can go away. Yeah, screw it, that works. Okay, undefined reference to you. Okay, so it does actually want those. Fine, let's just get rid of the ones that we don't need. I guess it doesn't really make a difference, does it? It's a lot of just random undefined crap all over the place. Let's define what we can. I'm starting to think that maybe there's a better way to do this. Okay, so you also need 16. You kind of don't appreciate how much code goes into the bootloader. Okay. So we only need a handful more files. So stir and copy. Stir and comp. And then we'll look up the other two one by one. So let's just add these. And copy. Okay, a few more files. At least the source code is really, like, modular, so it's easy to do this with. What was the other one I was missing? Stir our character. Oh, libsa. Okay, so now as undefined reference to FFS, which is fast file system. Alright, so that one's DawsFS, so we could just, like, get rid of it. It wants this function. Oh, easy. Alright, so let me grab that. libsa. Just kind of hope it builds. Okay, we're down to 2 functions. Okay, so let me get rid of DawsFS because I'm pretty sure we don't need that. In fact, I'm almost certain we don't need it. So that goes away. And that leaves us with exactly one thing it doesn't know what to do with. So it's right here. It doesn't know what to do. Has all the other functions. Okay. I have no idea if this is actually going to work, but is there a chance? Oh, there is actually a function in the C library. libc inet adder. Oh, it's in common. Okay. Alright, let's see if that builds. That did build. Yeah, it actually did build. It spat out an ELF file, so now we gotta fix the top level make file. So, yeah, it did that. And then I'm assuming it wants the size. Let's see here. Do I have a size? Yeah, okay, I do have a size. Okay. The question is, does this actually work? Okay, well, it built a bootloader. out NetBSD Motorola 68000 executable. So that is what I expect to see out. So the question is, does it bend? Yeah, we need to test this. Let's do a poll, chat. Let's see if our clutch together bootloader is going to work. Start poll. Will our clutched bootloader actually do something? All right, chat. Let's let democracy have its day. Wow, you people have faith in me. What is this? 12 votes, yeah. Oh, right, because I can't copy from this environment. That is... I might just have to set tail scale up just so I can flipping do that. That is annoying. Oh, ow, 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 ow. I am legitimately hurting. Alright, so boot. Clutch boot. Alright, let's see if it works. I think this is completely hung, actually. So, you know what? We're just going to give it a restart. It's an NFS mount. It doesn't matter. Chat, I'll be damned. That looks like it's doing its thing. I'm not sure that's the one I just built, but I mean, I think it is. Let's see if it actually starts. Well, we're going to be loading off NFS, the over network for the foreseeable future. Daniel Rodriguez, thank you for the 2,500 Chilean peso, I think. Well, that did a thing. Let's make a change to confirm that that is actually what we are doing. Oh, also, I just realized I made a mistake. I built the bootloader from 1.5. So, super hacked version. But, yeah, that was not the code I was intending to build, but it works. So, you know what? I don't think I can complain. I do want to load a slightly different copy of it. Okay. Let's reset machine. That is the goal of today done, but obviously I want to do more than that. Alright, so boot en NetBSD. Why didn't that work the first time? Yep, super hacked version boot. Okay, cool. That means I can build the bootloader from source, independent of the tree, which means I can do shit like testing the tool chain. That is actually really fucking useful. So the next question I have is, can I boot arbitrary binaries with this? Like, if I give it the boot.elf file, will it boot it? Quite possibly. I think, is there a way to break into, to send the debug interrupt? Because I know in real hardware, if you hit Control Option and multiply key on the numpad, it would drop you into the ROM monitor, and it would do that even if NeXTStep was running. I never tried NetBSD on real hardware. I always intended to, just never got around to doing it before I had to give up my NeXTstation. Ooh, I am hurty. Alright, so yeah, the next thing I want to do is I want to see if I can load arbitrary elf binaries. So let me take the elf file I have. Because this builds an elf. I'm really surprised that worked first try. I was not expecting that. I guess sometimes you get lucky. Alright, so what I want to do here is I want to take the Kludge Boot elf file, and I want to put that in root, export NeXT64 root. And I want to see if I can boot the bootloader with the bootloader. It might sound insane, but what I want to do is I want to see if I can load an arbitrary elf file. Because if that actually works, then we can start looking at trying to load the kernel. Because the next thing I want to do is I just want to be able to load a kernel binary, get into entry.s, and I want it to crash. That's explicitly what I want to do. The built-in bootloader only supports out and elf. It doesn't support anything else. Linux out is terrible for like 30 different reasons. I don't want to use it, period. When it comes to dealing with loading mock, which is going to be like phase 2 of this Grandmaster project, yeah. Once we have it loading an elf file, then I want to just do a simple hello with the pram, and make sure I can do that, because that means I can basically run. Because I know one of the issues that was on emulating the platform is the MMU is not 100%. The Next hardware was remarkably impressive and unimpressive at the same time. It's the Motorola processors that ran it were underpowered, and they were kind of obsolete even when the systems were new, which is why Next got off making hardware. Like, they still did to an extent, but like even the original Next Cube was not a particularly powerful machine. So Linux L32 kernel works from the NetBSD bootloader. Okay, so that means in theory I can just chuck a Motorola kernel binary in and call it good. I'll still have to set up the boot structure, which I looked at the code. There's no way NetBSD knows how to do this. The way it works in the Motorola 68000 port on the Linux kernel is that at the bottom of the kernel is a lot of configuration data that lets a platform generic entry point set up the MMU, and I think it also starts interrupts before it gets to platform coda, because I think Motorola I haven't even cracked the reference manual for the chipset yet. I know I'm going to have to do it, but I really don't want to do it. B Clanham, did you help write previous, or because I always have loved Next Step. I hate the fact I had to give up the physical hardware. Of all the things I had to do, that was the only one that really caused me pain. But I did make sure it found a home. There is a possibility I might someday get it back. You can load any standalone L32 binary. Yeah, but I still need to load the configuration strut below the binary, but that's not that terrible. It really isn't that terrible. Yeah, I am just letting this boot up, but I just want to make sure it actually still boots. It's just horrendously dogshit slow. Alright, so while we're doing that, I don't know if I actually care. Let me just see if I can load Kludge Boot from Kludge Boot, because that's going to be funny. Alright, reset machine. Okay, so it downloaded the binary and then it died. Why? It's possible the entry point is different, which from the ELF file. What is it going? Let's take a look at the code. Let's see what this actually does. I read through this last night, but I never quite figured out what it was doing. Okay, so load ELF 32. What are you looking for your entry point? I'm assuming it's just running the ELF entry point, so maybe the entry point... Or the bootloader might do something that is not happy with. Okay, because it would end up in start o.s or yeah, well, start 0. So we end up here, catches the exceptions. I don't think I can. Let me see here. Can I get it to dump me into monitor? No. That's unfortunate. So the question is, did we successfully load something? Because the numbers it prints out here do have meaning, and it prints out a whole bunch of them. I believe it prints out the BSS segment. So let's see here. We have load file. Right, and then it sends the progress marks. All right, just for shits and giggles, because this can load A out binaries. Let me try and load the A out version of itself and just see what it does. It's costly. The ELF file has got stuff in its header that... Oh, okay, right. File doesn't exist. Okay. Keeps trying to talk to Scuzzy. That's interesting. Let's just give it a good old reboot. All right, so inappropriate file. Okay, so it doesn't want to read the A out, which makes sense. NetBSD A out is likely different than what the bootloader, the raw monitor is willing to accept. Yeah, I know the boot prompt is that. Oh yeah, that makes sense. The it would probably it needs to load a different address. So how do I do that easily? Do we have a load address? Assuming that's the relocks function tells it where it is reloading to. I just want to read the ELF file to make sure I understand what I'm doing. Right, entry point address. So if it's just if it's just loaded, getting it into memory and loading in the entry point address, yeah, that would do it. So let me load. We'll move down to 4. That hopefully is still in the memory map. I'm gonna have to make a clean script. Okay, so that's at a different relocation point. So let's try that and see if it does something different. Oh, that worked. That was completely the problem. That was 100% the problem. So yeah, we can load arbitrary binaries. Neat, as they say. Yeah, I've considered using the Cube if I need to. It has partial NeXTcube emulation. It can load the ROM modder, but I don't think it has working Ethernet. And I don't think there's a way with NeXTStep with the ROM modder to load code over serial. Maybe there might be. If that is the case, that might actually be really useful. Let me see if it has an option to load from serial. See, the funny thing is the source code to the ROM modder is actually it's leaked. I don't know if it was actually published, but I know it's available. I could probably finish the emulation in QEMU. It wouldn't be the first time I've had to write a driver for it. So even if it's just to get the network working. Oh, it's working now. Okay, that's good to know. The Google had outdated information then. That's actually really good to know. That makes this way easier because with the QEMU debugger, I can examine the physical memory state really easily, which means that dealing with the MMU is a lot less obnoxious because that's really the... I'm not going to say it's the hardest part because I don't know if I'm going to be able to use the ROM modder. If it has working serial, that actually makes things way, way easier. I don't see a link to your fork. I'll have to hunt around for it, or let me see if I can find it now. Because YouTube filters out links in chat unless you're a moderator. I'm assuming that's not it. Yeah, that's definitely not it. Okay, that's good to know. Yeah, I'm gonna have to find that because the link got filtered out. Okay. Since we can load arbitrary ELF files, I feel like I want to just make a little hello world program and see if I can boot that. I do want to revert that though. because I'm basically just going to need this file. Let me look at main. Why am I not seeing main? Am I just blind? Oh, it's in there. Okay. Because this has code to talk to the ROM monitor. Yeah, here we go. Define monitor, blah, 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 MG, external, which I'm assuming comes from the next ROM file, which I should probably take a look at. All right, let's take a look and see what this does. So process, machine turbo, and then it does printfs. Char. Okay, so it's making parameter calls there. How does printf get wired out here? I'm assuming that's in machine dep here. Monitor, machine start. Yeah, that's how it's doing it. Okay. So it get character, put character from the ROM monitor. Probably means I'm going to lose the ROM monitor as soon as I enable the MMU. If, I mean, it might stick around. It depends on how the MMU is set up. Yeah, we have all the trap code here. So what is actually in... Let's open a new window. Let me see what the ROM monitor actually gives me. Not sure how much farther I'm going to take it today, but if we get a hello world binary going, it would actually be quite good. Next ROM. All right. Okay, so it doesn't have that many functions, but it's good to know what it does have. DMA, interrupt strategy, interrupt mask, get C, put C, boot slider, event. So talking to the ROM monitor should be relatively straightforward. Let me look at the chat. All right, so you're looking for, I'm looking for the Cume next repo. Oh, yep, here it is. This is it. Let's look at commit history. Yeah, that's good to know. That is very good to know. So yeah, that does give me a full debugger and more. So that means I need to set this up is what this actually means. Which is not the worst thing in the world. I remember doing ton networking on QEMU in Windows is kind of hell on earth. It wasn't fun getting it working as is, but there are worse things. So yeah, I think what I want to do next is I just want to make a minimal Hello World C just to make sure I can actually do it. Like, it just feels like a smart move. Because basically I need to copy this code over. I need to make it build without the headers. Which shouldn't be terrible. Yeah, why don't we do that? So let's make a new folder. Let's do hello. I am recording this, right? Yeah, I am. And let's just copy the everything from here to our new make file over here. And this all goes away. So our program is now low. We're going to load it at a new load address. Let's copy you. Put you in there. And then let's see if we can just get rid of these includes, because I kind of want this to basically be a very simple thing. Okay, so now we need to delete the headers out of here. I don't remember what I have to do to make it export. Right, it's going to be like that. This particular file I actually copied over, so you know what, I'm just going to... basically keep it as simple as I can do. Sheen.asm not... Oh, okay. Where is that file? Oh, that's right. This step links it in. Let me just copy it because it's going to be less annoying. NetBSD source. And we just make that reference the local one. Sometimes I just feel like technology just hates me. Can't create regular file. Is that because I have it open in here? It shouldn't be. Weird. Okay. Alright, so that assembled. That's good. So now we want to just basically put a main function on this. So we just make the simplest, stupidest boot.c. Yeah, we're just basically gonna do that. Undefined reference to MG, undefined reference to trap. Okay, that makes sense because that's those are other bits of code I know are used. External character, because we want to be able to call the raw modder, so we need to grab that. And I guess there's trap code here that I'm going to need to find. Actually, I'm pretty sure that was in machine dep. Yeah, yeah, it was this. It was basically all this. So I actually want all this because that's trap frames, dead code. Let's just grab trap for now. We'll come back and grab the other stuff. Except that actually uses printf, which I don't really have. So what we'll do instead is we're just going to comment that out. And we're just going to loop forever if it happens. Alright, what is it complaining about? Oh, it... Really? Right, I guess because the types aren't actually defined. There are no C types. Oh man, I forgot. Honestly, it's been so long since I've done bare metal programming, I forgot how little you actually get from the compiler and all of its in-flipping headers. This doesn't drive me up a wall. Where are you getting your definitions from? Yeah, you get it from sys types. I don't need it completely clean of old code, so you know what? I just basically want the minimum. No include path and for which to search in. You have // Oh, it would be... Yeah. I need a less bad way to handle that. I really need a less bad way to handle that. Okay, undefined reference to MG. Because that's the pointer to... Is that in the next ROM header? It might be. Or is this just the includes? Undefined reference to MG. MG is pi. Okay, no, it is defined in machine DAP. Yeah, it's defined here. Okay, so that actually built something. Ow. I might have to end streaming early just because I'm actually in a lot of pain today. Oh wow, you guys have been talking for a while. Plan 9 for next. You have the source code, but you don't have binaries, I assume? Well, it's right now I'm trying to get the next bootloader to do stuff with bare metal. And honestly, putting something... Like, if I can just do a Hello World, I think it would be a good idea. So let me see if I can get enough code to just do that. Before my back decides it's just not going to have it anymore. Alright, so if I want these macros to work... Alright, I need the ROM definition headers. Okay, that builds. So let's put a character in and see if it does something. Alright, so we have two versions of this file, hello.elf and hello. Let's try the elf version first. Okay. Why didn't it see it? Oh, because it's not in the right place. Well, that did something. Yeah, it triggered an exception and then died. Okay. Well, that's doing a thing. Oh, maybe because it's probably returning. Yeah, it's returning. Let's put an infinite loop in this just to see, because it is clearing screen. I don't know if that means anything. Well, that's, like I said, that's doing something. So I'm going to at some point learn how the exception code works. Like I said, I always wanted to port an operating system, and if I don't do it, it'll never get done. And it's something for my own satisfaction. Just like to prove to myself that I can actually do it. So what are we doing that's causing it to go completely? Character boot int. It's possible that we're not doing something with the raw monitor that we should. All right, let's make our hello world program simpler. Let's just try breaking into an infinite loop and see if that does anything. No, it just crashes. Wait. No, I didn't change this. No, there's no difference. So that's not the issue. Call C. Okay, I am legitimately confused. We are basically doing nothing different. The SRT0 code is identical. They compile to the same object file. So maybe a problem with how we're putting the object file together? We set the entry point to start, which is correct. I mean, I just copy and pasted this code. What gives? Linux. I'm going to try and see if I can get Linux to run. There's no port of the Linux kernel to Next hardware. I was able to boot the bootloader off the bootloader, so I know this at least works in theory. I moved this into a different part of RAM, so it went overwrite. This should not hurt us, i.e. cause an exception. Alright, you know what? Let's just have it get stuck in an infinite loop. Let's see if it if it even gets this far. Oh, it does. That's stuck in our infinite loop. So we did make it into start. Wait, looking at this code, I think I see the problem. I don't think we have a BSS section. Yeah, that would do it. Because I don't think we have anything uninitialized. BSS is 4. So it's not empty, but I have that distinct feeling that if we move our crash code... Branch is not equal. Yeah, let's put it here. I'm pretty sure this is where we're crashing. No, that is not where we're crashing. We get further. So where in this code are we actually crashing? Let's try right before we jump to C. I've got the libsa stuff, which will work as a basic library. Right now, I just want to see if I can basically run a minimum binary. I am down confused. So this would imply that we are actually crashing when we try to jump to main. Which is here. And we don't make it. I'm gonna try it there. I don't think that would be it. Okay. Like, I'm pretty sure this is gonna do exactly the same thing, but I want to rule it out. Yeah, same exact thing. So we died crashing, we died jumping into main? That, the fuck? Where is main? What is exception free? I'm assuming that's the... Address error. Yeah, OXC. Address error. OX10003. This memory address is a little bit odd to me. Why is it that we get an address error? Yeah, I'm assuming it's the ROM default trap handler, although we set up vectors on this. Yeah, catch exceptions, copy for trap 13, use the new table. So we do set up our own vector table. We shouldn't be crashing into... We have interrupts off. I am seriously confused on how this is possible. And there isn't even that much code here. Okay, so we end up in start, D6. Both possible code paths end up in an infinite loop. We're just not jumping into C correctly. Yeah, because I comment all this out and we just go into an infinite loop. We go into an infinite loop here, and we don't call these functions. We disallow interrupts. we shouldn't be ending up here. We must be going through our... Okay, hold on. Assuming this code actually works, we set up our own interrupt table, and that gets made down here, trap 16 as trap, and then as trap jumps us into the C code, which pointers to registers, and then jump to C instruction label trap. But trap should be an infinite loop. Yeah, it's a vape. It's Apple something. I hate the fact that I'm smoking at all, but it's what it is. I am deeply, deeply confused here. Are we going down the... Are we trapping? Let's start with that. Let's put a loop point here. And see if that changes things. So we're not going down the trap code path. Are we returning? Yeah, just like that shouldn't be possible, but just because I'm starting to lose my mind here. Always check for the impossible, because sometimes the impossible is happening for reasons you don't comprehend. The fuck? We are returning. Because that's not an infinite loop. I'm an idiot. That evaluates... Yeah, okay. I'm amazed that this code structure is valid. Okay, I am a complete idiot. For those who can see it, you can realize what I did. Yeah, okay. I am... We are returning from this function, and that's why it's doing that thing. Because this is compiling as this. I'm big smart. I really am. I can't believe I did that. Okay. All right. All right, you know what? We're just gonna make it print 30. We're just gonna make it print a lot of H's. Why is it? Oh, Lord. Yeah, I can kind of tell I'm not firing on all mental cylinders today. Well, that's interesting. It did absolutely nothing. At least it stopped where it was supposed to. So I will take that as a good sign. I'm pretty sure... so put character... Yeah, I don't think I define a value to MG anywhere. So let's look at the code. All right, at least we're now back in territory I understand. So MG is supposed to get set by the bootloader, blah, 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 blah. That all makes sense to me. So we put character, character gets put, and then we get infinite looped. Windows and... Nope, that opened a top... How do I get rid of that? Okay, so that did break me out to the monitor. Cool. Alright, I was trying to figure out what that key shortcut was to actually do that. So that's all the registers. So the registers tell me where I actually am. Print memory configuration, print address configuration. That's actually really helpful. The question now is, why didn't it do anything? So we have put character here. Is there something else has to get flushed to make it, like, do the thingy? I am also assuming the MG pointer is good, but we've seen it work before, so I'm... So MG should get set off. Type UN. Yeah, so it does. It basically does a function call into the parameter round, into the ROM monitor, which is what this code does. And I've got that here, or not here. Yeah, so that's there. Put character. Don't know how long I'm going to stream for. I'm really feeling the pain today. Well, that worked. I mean, it's screaming at us, but it's working. Yeah, so if I hit Windows Tide, I pull up... Yeah, it gets caught by the OS. Thank you. And now I've made it big. Yeah, so the problem is when I hit Windows Tide, that is... It pulls up that instead of going through to the emulator. It worked once. All right, so Control C. Okay, so that does work to reset. Let me try Alt Tab. See, it sometimes like works. Like that time, oh, maybe because if the mouse is locked. Yeah, if the mouse is locked, I can reset into it. Okay, that is good to know. Okay, so that does mean I have access to the ROM monitor. That is really handy. So I'm guessing I have to do... let's see if we can actually get a hello world out of this. I mean, maybe there's a buffer of some kind. All right. And I'll put a new line, which may be what it actually needs. All right. Let's do a make. A copy. Hey, there we go. Hello world. That is nifty. That is actually really nifty. And I have a sandwich here with my name on it. So I'm going to chew on this while I think about what to do next. My thought is we're going to have to build a Motorola 68000 kernel. Now, one thing I do want to check is I want to see if I can boot it from the out file that it generated. I want to see how generalized that pack is. Oh, that's tasty. Okay, so we can talk to the prom. We've got access to the ROM modder as a debugger. We can load ELF files arbitrarily. It doesn't seem like I would have to do all that much to actually get into the kernel at this point. I don't know if I have Linus's tree handy on this machine. I have it on the laptop. But let's take a look at the code that we need to deal with. I haven't also decided if I'm going to do a modern kernel or if I'm going to do an old one. But if we look at Motorola 68000. Here it is, entry S. So this is where basically every bit of code enters. This is a common entry point. This is where everything enters. And you can see it does a whole lot of setup, but it's just generic Motorola 68000 stuff and the MMU stuff, which is basically all the same. And then if we keep going down, you gotta go down quite a lot. Yeah, so it does some checks here. Am I in the wrong part of the code? So not entry dot... Oh, it's head.s. That's the wrong one. Yeah, this is where it enters. And you get a lot of stuff here. Like, it's got all these checks for not Amiga, not Atari, yada, yada, yada. And then this is the structure that has to basically exist. Right, and then records the machine type, the FPU type, and all that. It checks if it's a 6060, 640, or 620, or 68000. Yeah, close enough. Just eating a late lunch here while I think about it. Yeah, so like all this code is common. It gets quite far, and then you start getting to the Atari specific parts, Motorola VMB boards, and so forth and so on. So, and when I looked at the next step code, it was also really similar. Because here we get to the setting up the I/O maps and such. Like for the HP 3000, it literally is just one memory zone, and a few other ones are more complex. And I'm having that problem with the PETA where you can't get the wrapping paper down. Well, that's the entire level of paper I don't need. A lot of the boot protocols are bespoke. The Motorola 68000 port in the Linux kernel was... I want to say it was the second one ever done after x86. I know Debian's Motorola 68000 port was second. I'm pretty sure that was true in the kernel itself, although it is possible either Alpha or MIPS predates it, but I'm pretty sure Motorola 68000 was the second port ever done in the kernel. And a lot of that back in those days was basically just throwing shit to make it work. I would have to turn back the kernel history. Like, I'd have to go way back. Would it have been 2.0 or would it have even been 1.2? I'm actually now deeply curious. How far back do the tags in this go? Tags don't go back that far. I want to say it was 2.0 was the first one with a portable kernel, but it might have been 1.2. Oh, you're going to actually make me download. I want to look it on Git, please. Close enough. Arch. Yeah, okay, no. So MIPS, Alpha, and Spark. So Motorola 68000 port wasn't even in the kernel with 1.2. This was back when Linux was still a hobbyist project for the most part. Like, the Free Software Foundation was basically getting all in on this bandwagon. And the idea was they want to get Linux running on a lot of stuff. The easiest thing to get Linux running on is stuff that runs Unix. And most of this was done in the 90s. Like, 6800 Unix stations were definitely on the way out. So I'm guessing it must have been Linux 2.0 was Motorola 68000 support. Oh, it was in 0.99 for the Amiga? Okay. It must have been a separate tree then. Yeah, it doesn't surprise me it was for Amiga. It's about the only thing that still uses the original port. I'm actually surprised Linus hasn't killed it out, the tree. Most modern Linux 68000 stuff is cold fire. Now, I don't think I've ever read his rant. I can guess what it is because I'm familiar with... it feels like good reading material. I don't care space aliens ate my lunch. Okay, hold on. Is this actually here? Yeah, here it is. Okay, this is going to be an amusing read. Let's make this big. Apple doesn't want other operating systems on their machines. You'll find nothing written on the Apple Macintosh. That's partially correct. A lot of the early Macintosh stuff was actually fairly well documented in Inside Macintosh. It had a full printout of the toolkit ROM stuff. But the later ones in the 90s did not. The platform basically got more proprietary over time, but the information was true. That's a valid point. He may have not... And I can guess that some of the Inside Macintosh stuff wasn't accurate. Talk about the interested in real operating system. Quaint, buy a new computer. Yeah, that hasn't changed. The third barrier to Linux support is less obvious and linked by the lack of documentation. Certain folks have speculated in embarrassment the main reason Apple Computer is releasing so little documentation. The Macintosh platform in general have the positive Stone Age design positively Stone Age design features. Yeah, that I knew. Interrupt controllers on the Macintosh 2 are a pair of 6522 VIA chips intended for use with the 8-bit 6502 processor. I feel like there was a technical reason they did that. I knew that there was some really stupid, interesting design decisions. Complete lack of DMA makes sense because classic system software could not handle DMA. It was a remarkably primitive operating system. I've seen Diebold stuff stare. I still remember the voting machine controversy with them. Not the hack voting machine, but when electronic voting was starting to get out, that people were saying, "Oh God, people are going to hack this." You know, it turns out, yeah, voting machines have a lot of security problems. The technical security problems are not the problems that we need to be worrying about. Mac Callcast, I felt safe in helping in the direction of port, lacked an MMU, I enable. Okay, very basic. This is talking about the getting the boot system. So they used OpenBSD. I did not know this. I didn't know this article existed. I've seen Linus's rant on Apple computers, but that's much more modern. And I am trying to liberate my lunch from its wrapper. Come on. Preferably without making a mess on my desk. Good enough. This is a fun read. I had Macintosh Bath to laugh at. I had no MMU in my Macintosh, so I couldn't possibly help write any code. And the solution to this is that someone will give him an MMU. Yeah, that's exactly what happened. And then Frank Newman sent me an MMU for the Mac 2, and someone else donated a pair of Ethernet cards. Yeah, I've had this happen. Having the MMU fitted to the Macintosh without blowing it up was easy. Mac OS has 2 error messages? Yeah, basically. This sounds about right. They therefore sensibly shipped a system ROM that wasn't capable of running with the MMU enabled. Yeah, this sounds like everything I've ever tried to do with development on classic Mac OS. I hate them as a platform. They're a pain in the ass to work on those machines, and they suck for doing anything. OpenBSD loader was pure macOS wizardry at a level far beyond behaviors. And the OpenBSD loader could be persuaded to load Linux. Okay, this sounds familiar. Building of a cross compiler. Yep, I knew. Oh, that would have been GCC 2 era. Good luck. That. Oh yeah. almost generating the right code. Okay. So one of the big problems you had in GCC 2 was the build system was a little bit insane. GCC 3 was a major fix. Here was a major pain in the ass, and you can get very subtle differences, and this sounds exactly like that. Linux AOut executables have a 2 different byte header to the OpenBSD ones, and the bootloader checklist. That would have been the AOut platform bits. AOut wasn't so much a standard as something every compiler did slightly differently and was sometimes mutually compatible. Okay, White, most content to build for Macintosh Target, filled everything that complained with dummy routines for Macintosh keyboards, mice, displays. Yeah, adding a completely new processor port's much difficult. This is me just kind of getting the hardware. Like, I don't actually expect it that hard to at least get in the kernel and then crash. Actually, starting the kernel may be a bit more questionable. We'll see how far we actually get. Oh, yeah. Yeah, I knew this problem. The Motorola 68,000, the 851, which I think is the MMU. No, the MMU is the 881. Combination of chips is obsolete. Motorola didn't carry the documentation. Yeah, I knew that was coming. One of the biggest problems I knew with Motorola was it was notoriously difficult to get documentation out of them. They basically, it was only what they were selling, they were doing, and this would have been... Cox would have been doing this, I didn't see if there was a date, but I would say mid to late 90s, when Motorola was trying to get everyone to start switching over to PowerPC. Alright, so you got a Macintosh that got to a blue screen and waited. I'm sorry I'm not reading this out loud, but I just kind of enjoying looking at this. Hardest thing to get going, dealing with an unknown environment, no idea what's going around in your code, extremely tricky to debug. Use logic analyzers, several things in the process, that the Macintosh screen memory isn't located where the hardware claims it is until you set up the MMU. I also made the amazing discovery that the rounded corners on the Macintosh are drawn in software. So the way he did this is he basically figured out how to access the video memory and then made it flash colors as it went through the early initialization code. Yeah, it's basically the way I would have done it. Or, yeah, no, that would probably have been the easiest way, because with Macintosh, you really have to have the frame buffer at the start. And getting serial output from a Mac to a PC is not trivial, at least in that era, because it wasn't RS-232 on the Mac side. You needed a fair number of adapters to make that work. Fill-in support for the 4-pack pixel displays that were used by the Tobii video card. Generic bitcap cancel drivers for the 68,000 supported a wide variety of pixel formats and excluded the one I needed. Machine still very mysteriously crashed. A structure getting stomped on. Yes. GNU linker was at fault, and in some places loading a completely bogus address for the relocation. Yeah, so that got him all the way to unable to mount root file system, which is basically the sign that the kernel's ready to go to userland. And then this is talking about dealing with all the various hardware stuff. Yep. RAM vase video. Okay. This was definitely an interesting read through on what basically doing what I'm going to be trying to do. Although I have more to work with than he did. I'm just legitimately... Wow, I'm feeling a little lightheaded. Yeah, it's definitely been... this... Definitely... Oh. Memory was mapped to alternate every 16 bits in its address space. Yeah, so this is now so now he's got booting up to wanting a root file system. He's going to be doing what I'm going to be doing and doing it with NFS. Just trying to get my last bit of my lunch free. Wow, they really, really wrap this tightly. That was a good pita. So use a distribution called Watchtower. Okay. Neat. All right. So yeah, so this is basically what I was expecting. That was a great read. Thank you. So we did get Hello World to work. I think the next thing I want to do is... What is the easiest way to run an existing Linux distribution? Is Cume's Amiga emulation up to snuff? I'm pretty sure you could run Debian in WinUAE, because I would want to build a standard kernel, test it, and then... I'm just having a legitimate think about it, where I go from here. I think I would want to set up a build environment for a Linux cross compiler. QEmu's Max 68K support. Yeah, okay, yeah, that makes the most, that makes a lot of sense. Actually getting that running is going to be kind of a pain in the ass. Just because I expect it to be a pain. Anything involving classic Macintosh is always a pain. But we would basically want to set up a Motorola 68000 root environment. The real question in my head is, do I do this with a modern kernel or do I do this with an old kernel? Because if I do it with an old kernel, it's more likely to actually be effing usable, and it's not going to be terrible to get it. If you get it working on one, getting it working on the other should not be terrible. Although I remember what NetBSD VAX was like at 25 megahertz, and this feels slower than the VAX. So, Maze, you actually built a full port of the kernel to Next hardware. Yeah, I know it's going to produce big binaries. I was thinking of using the kernel from Debian Etch, which was the last Debian release that supported Motorola 68000, and ironically was like the first Debian release I actually worked on. Oh, okay, interesting. I still think I'm going to do it for myself, just to learn how to do it, but it's nice to have reference. Because what I'm thinking, there's 4 versions of the mock kernel. That is the next step kernel in existence. There's a copy of the source code from NeXtStep 2.2, I think, which has the kernel source code. I don't think it's leaked code because Next had a written offer to get the mock source code in some of their earliest manuals. And I'm pretty sure that came from Next. I don't think it was proprietary in that sense. I looked at it very briefly just to see what was in there. So there's the Darwin 0.9 kernel, which is actually Rhapsody 5.3 and is compatible on x86, binary compatible with both NeXtStep and OpenStep. I know that one for a fact because I've built that one from source. So my thought process here is, once I'm happy enough with my skill set to actually like take this on, is to try and get the NeXtStep kernel, the Rhapsody 5.3 kernel building for Motorola 68000. A fair bit of the stub code is there. All the drivers are binary in user space. Yeah, Yeah, that's the biggest problem. It is missing drivers. I guess I would only really need the Ethernet one, which might not be the worst thing in the world to try and build. I have to seriously think about that. The upside to that is it would give me a full... See, the compiler is the other major problem here. Apple's CC tools for Darwin, up until they dropped GCC, still would build the Motorola 68000 target if you built it on NeXTSTEP, and it is known to build and it is known to work. The problem is that the way Rhapsody and Darwin build, they're not freestanding. They have to be built off basically themselves or a very close version. It's actually a giant nightmare to get that piece of shit to build. Which means that in practice, I have to build it for the host architecture. I have to convince GCC to build. And then I would have to build... I would basically have to build it on NeXTSTEP or OpenStep 4.2 with universal binaries for x86 and x60 i386. That would let the toolchain build on i386 targeting Motorola 68000. Doing it in Darwin is going to be way harder because I'd have to get libsystem to build. Getting libsystem to build would not be trivial because the whole thing is built upon itself. It's actually kind of a nightmare. But that would let me build the base system, or at least as much of it as I could. Because once I could build CC tools... I'm almost wondering if just starting from Rhapsody is the easiest way to do it. And then... No, because the C compiler isn't freestanding. That's the nightmare. I'd have to convince the CC tools to do a freestanding build, and then use that to build X and U and the core system libraries. I'm like thinking of 6 steps from now. Yep. Like I said, I do want to do the Linux port myself, just because I do want to port an operating system, and then, well, I want to port a kernel, and then we'll go from there. Right now, I'm just mentally thinking about where I go next. I think... I think setting up a cross-compiler for Motorola 68000 makes the most sense, to be honest. I don't remember what version of GCC Etch used. I really don't want it to be GCC 3. I really don't want it to be GCC. Because Etch was the last one that supported Motorola 6. GCC 4.1. Okay, 4.1 I can work with. Because if it was GCC 3, building a cross-compiler is a lot more miserable. And I could probably use 4.6 or 4.4, which I know builds really well. I think I used 4.6 when we were on Interex, or... No, I used 4.7. Yeah, I've built the Rhapsody source code that was released by Apple as Darwin 0.9. I've actually built that from source. I did that with NeoZ years ago. It's a completely insane build system. It actually uses DPack and is hell on earth. There's also a lot of other pain points because the IDE driver in NeXTStep doesn't work very well. You have to run it on SCSI, but I remember it having a lot of issues. It probably would work okay in 86 box, although it's not going to be performant on 86 box. But the problem is that the source tree is so flipping large that you run into partition size limitations that really suck. And NeXTStep and macOS has its NFS implementation sucks because they built it directly on the mock kernel API, so it uses mock IPC. So it's absolutely terrible. Later Darwin's did fix that, but it's why NFS and NeXTStep is such hot garbage. It works fine when it talks to other Next machines, but when you try and talk to, say, Linux, it just shits the bed. Use GCC 14 or 15 to compile for Next. The only reason I'm thinking of using an older compiler is that sometimes a new compiler on an old one kind of like goes kablooey. There is a part of me that kind of wants to go with the new kernel for shits and giggles, and I can just backport it. Like, at this point, the more I look at it, the more I don't expect this to actually be that much code to get for the early boot. Because if we look at what we have to do to get to start kernel, I need to pull up Linus's tree. Here we go, Linus's tree. So if we look at Arch, Motorola 68000, where we want to end up at is start kernel. And start kernel is called from, is it the end of entry.s? Where is it called? Maybe it's in seb.c? No, I don't remember where it's called from. Wow, there's a lot of if statements in here. This code feels very spaghetti. Show CPU info. Yeah, a lot of if-thens for doing the config stuff. So process uboot command line, which we don't care about. I don't remember where start kernel is. Just set up the MMU and set up the RTC to get it going to start kernel. Okay, well that sounds pretty easy. And then I realistically would just need the frame buffer. Yeah, I would need frame buffer, and I need Ethernet. And I don't know if Linux supports the chipset. If not, I have the NetBSD driver. It's not terrible to port that over. Like, network drivers in Linux are really fucking simple. Yeah, you just go to net. Let's just pick one at random. I don't know if I should actually say simple, but they're not the most complicated things. Driver code tends to just be a lot of setting registers and interrupt callbacks. So, why am I not... Oh, because net, it's drivers. That's right. Net... Yeah, like, let's... If we open up, like, Apple... Yeah, like, this is the network driver for a Power Mac Ethernet adapter. It's mostly DMA register, and it's mostly just implementing these functions, which are more or less one-to-one with the NetBSD API. Like, it's a little different, but as long as you know how it works, and I can always look at the emulator implementation if there's no chipset code available, it should be simple enough. NextDMA has some weird cases that will bite you in the ass. I did see a fair bit of code relating to DMA in NetBSD. NetBSD source. The one thing that I am a little bit interested / confused on is I have, looking at some of the code that I've seen in OpenBSD, I'm not convinced that this is I'm not convinced that this is a clean implementation, because it shares a lot of characteristics of what I've seen in Darwin and Rhapsody, some of the platform code. I have this feeling that this source code was based on the next step code. I don't think it's a clean room implementation. Oh, that's open file. I wanted open folder. Yeah, I trust the offers, but that is not the folder I'm looking for. NetBSD source. There we go. Arch. Yeah, so on this platform, yeah, there's a lot of PMAP bootstrap stuff, which is the MMU stuff, platform MMU. Mock dep stuff. It might have been code from Plan 9, but I wouldn't be surprised if... From what I've seen, Next basically made no real modifications to Mock except to add their own hardware. They later then added the kernel Objective-C interface, which I don't remember if that was in Next Step 1. I know it's there in 3.3, the K Object-C API. But I don't think it was there at the beginning, because they really did not change Mock a lot over the history of Next hardware. The kernel itself was... And it shows Mock is a pig. It's not a well-designed kernel, and Apple kind of made a miracle getting performance out of it. And I have a lot of familiarity with Mock IPC because I used to hack on Herd as a hobby. Okay, so this looks like a lot of... So with Plan 9, we have the source code, we just don't have binaries. Is that basically what it boils down to? Because that might be an interesting project to take on if I can find an old enough version of Plan 9. Because Plan 9's C compiler was a cross compiler. So yeah, the one thing that caught my eye the most when I was looking at it was actually in the standalone boot code. The the next ROM stuff looked right out of some of the internal Next code that I briefly looked at. It might not be the same, but it uses the same name for the variable and stuff. But the Plan 9 code could have been easily based off that. Plan 9 was not CMU. Who was Plan 9 MIT? I have almost never touched Plan 9, so I only know it in an academic sense. Yeah, just the source. I have to decide how much I hate my life if I really want to try that, because I'd have to learn how to use Plan 9. I don't even know if any of the surviving... Like, I know the source code to Plan 9 is well preserved, but I'm pretty sure a lot of the binary builds for non-x86 have been lost to time. Plan 9 was AT&T. Yeah, okay, it was AT&T. I am completely just mentally cooked. So the only really hard part... Let me see. Let me look at the platform the mmap bootstrap for this. PMap copy 1.2 bootstrap VM system. Blah 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 blah. First available returns an updated PMap bootstrap. Kernel segment pages came a blah blah blah. So this is just doing all the math. Valid bits that essentially mandatory free level structure. Last part of the code. Like, how much of this is Next specific? That's the part I'm trying to figure out. Because this code's referencing Motorola 68000. Like, if we look at News 64 and we take a look at its folder. Yeah, you see, it also has a PMap bootstrap. Select for compare. Like, what is different between these two files? Because that's going to tell me something about the bootstrap code. Ah, it is different. But it doesn't look different in a way that... Yeah, these are just different versions of the same file. It's like a... Oh, this file... Okay, so this version says this file is taken from resynced when needed, CSV ID. So it was based off a common file, and then they made changes to it, but of course they didn't mark what the next step specific changes were. Because that would be, like, way too fucking easy. Yeah. From what like I said, from what I've saw under the hood, the basic way Next operated is they basically used Mach and Unix as kind of a shortcut. Their entire business model was basically Objective-C is the future, object-oriented programming, buzzword, 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 buzzword. On a technical level, NeXTSTEP is quite elegant with the way Objective-C works. I mean, in that regard, it was ahead of its time, and Swift basically keeps the best parts of Objective-C and just drops the C. The problem with the original NeXTSTEP is that it suffered a lot because Mach is just a pig of a kernel, and a lot of the early code was not well optimized. Like, from what I've seen, they basically supported Unix out of spite because it was the easiest way to build a workstation without and just focus on what they wanted. Like, they basically made the entire thing to run Objective-C and threw everything else out. All right, let's do the next thing, since I've still got some energy, and let's just put together a quick and dirty Motorola 68000 cross compiler. You don't need a whole lot to make this work. FTP ports. Okay, that's basically what I need. I think I can just do include variant build D. We'll do variant build D include Linux libc dev. That might already get included, but I'll include it. Let's see here. Arch MX6 SID Debian SID M68K. Okay, there we go. That's downloading a chroot. Fortunately, building the compiler here is going to be pretty easy. Oh, that's right. Isn't there a built-in cross compiler? Yeah. I remember when these were added, but I'm so used to building them from scratch because I'm doing weird shit that I can almost never use them. Let me pull down Linus's tree. Yeah, let's pull down Linus's tree. Yeah, I know, that's fine. That's going to take a while. I have nightmares of using userland emulation back in the day that have kind of scarred me from it. Is it at the point that that userland Motorola 68000 actually works like well? Because last time I played with it, which admittedly it was like 10 years ago, it was only doing cold fire and had very limited support. I know it's gone better since, but I'm very much out of the loop on that one. Oh god, why do I really want the full Linus tree? I guess I do kind of want the full Linus tree. Yeah. All right. I'm going to grab a drink. I'll be right back. So I did have a thought while I completely forgot to get a drink. Let me go get a drink and then I'll talk about my thought. Energy drink number 1. Is Linus's tree really 10 gigabytes? It's been a while since I've had to check out the whole thing. I don't want to do a shallow clone just to have to unshallow it, so it's whatever. I can think about it. So, going back to what I remember about next steps internals. While we don't have the source code to the Motorola 68000 part of... I have to make a differentiation here. There's Mach, and then there's XNU. XNU is the kernel from macOS 10. It's based off NeXTSTEP's Mach, but they are distinct, and we can't use them interchangeably. So we have the source code to Mach from NeXTSTEP 2.2, which is unknown. I've never actually, aside from taking a brief glance at the code, I've never tried to build it. We might try that because while I normally don't like touching like questionable source code, this shit is now almost over 40 years old. And who cares? I'm targeting hardware that is almost older than I am. We have that, and assuming if it's complete and buildable, it would probably be pretty straightforward to port that to the later mock kernel. I just don't know if I really want to use Next's own code for that. It's an option. I just haven't decided if it's an option I want to take. If we look at the Rhapsody source code that is available and was officially published under the Apple open source license, so this is completely legal free code, no legal problems code. We have the i386 port and I believe the PowerPC code for Rhapsody 5.2, or it may be 5.3, but it was basically what became macOS 10 Server 1.0, which was essentially just NeXTStation with the platinum look and feel. That code is known to build. I've built it personally, and the entire tree can be built, but you have to build it on Rhapsody, and it really wants to be built in PowerPC. It will build on Intel, but I remember I had to really hit it with a stick to make it do that. The Rhapsody code does not have the Motorola 68000 stuff in it. But, and actually I am going to boot into NeXTStation for this because I want to take a look and see what's actually there. We should have the full kernel headers available. It's SD. And we should also somewhere have the CMU mock code, and that should be legally free and clear. I know NeXTStation 2 is based on Mach 2.5. I don't remember if they upgraded it to Mach 3. They might have, and I don't know of a Motorola 68000 code port. Because if I can reuse the original code that NeXTStation based their code on, I have a higher chance of making this all work. And what I am looking for is the realization I had when I was using the head was that while I don't have the binary code, I should still have all the kernel source headers. And if I have the source headers, I know the function calls that need to exist, as well as all the data structures. Which means it gets a lot easier in some respects. I don't have to write all the code from scratch. I actually am wondering if Ghidra would be able to parse mock kernel. It has symbols, so I might be able to just reverse engineer the kernel binary. All right, let me take a look here. Let's go into Next Developer. Let's just use the UI for this. I don't remember the mock stuff. Maybe I have to actually go to the command line. NeXTStation likes to it's you can see where macOS gets a lot of its quirks from. They were baked in from the start when it was still NeXTStation. All right, so where would the mock kernel stuff be on here? So this I install. You cannot, as far as I can tell, install OpenStep 4.2 directly on 6800 hardware. I had to upgrade it from NeXTStation 3.3. Okay, so IDA Pro did work. Okay, that's good to know. I assumed it would because it has to know what mock files are. And there are other platforms that use Mach-O. Actually, Herd is the exception. It's the only mock-based kernel that doesn't use Mach-O. Hold on, is that true? I'm pretty sure True64, which was mock-based, was Mach-O binary. So, although maybe they were ELF. They might have been ELF. All right, that is not working. Yeah, so that's all the stuff for Mach, or for GCC. I want to say it's in NeXTDeveloper. Or not. I'd have to reinstall the dev tools. I know I installed the dev tools. I mean, I have CC on here. So the question is, why can't I find... Let me go look into private. Drivers net... Preserve VM. Those are just logs. I was right. NeXTDeveloper does install stuff here. But where's the... Did I not install all the headers or something? I must have not installed the headers. Or let me see here. Let me eject that CD and let me put in the developer tools. Please eject drive and external disk. What? That was weird. Let's eject that and then try put the disk back in. Insert. Developer. Okay, that worked. Okay, so the headers are here. Okay, so we do have Mach. What do we... Yeah, okay, so we do have these. So... Let's see what we actually are working with here. Just to get an idea of the nightmare I'm about to embark on. So let me grab the let me see if I can find the Mach 2.5 source code. I'm looking for the CMU Mach 2.5 source code. Okay, that's actually interesting. So I didn't realize this. So XNU, or at least next step. Let me see here. Dmessage. It's on host info. Yeah. Okay. So next internally called the kernel MK, and I guess I didn't realize that was from CNU. So the question now becomes, is how much of this code was basically surviving? Mach MK. Oh, I don't want Call of Duty. Let me see if I can find it on GitHub. I am just curious on how much has actually survived. So this is Mach 3. Kernel. And you only have... Do you only have Intel code? You only have Intel code. This is a Mach 3 kernel. I think I'm looking for a Mach 2.5. Elo... Is that a Greek name? I'm not sure what your woe is in reference to. So that's OSF's next. I remember NeoZed. Okay, so it was Intel only. So what's on the X60? Yeah, I remember NeoZ played with us. Support for Sun 3. Sun 3 was Motorola 68000, wasn't it? Yeah, because I remember NeoZ played with this quite heavily. And even if it has just basic, let's see here, so CD4, SEC files, Berkeley systems. Okay, so apparently you need to still buy the CSRG archives on... Let me look at the Unix Heritage Society. If anyone has it, they would. Otherwise, I could just ask Neozid because I know he had. Let's see here. Unix archive. Let's take a look here. Looking for other. Bunch of old Ultrix. Okay, that's not looking promising. Oh, interesting. Okay, thank you, Neozid. You posted source walls. God, remember when SourceForge used to actually be nice to use? Yeah, 86020 is not ideal, but it might at least give me an idea of what. I just want to see if I have a non-legally encumbered version of any of the platform code. Are you fucking kidding me? Why can't you extract? That didn't look promising. That I could already see. Yeah, it doesn't have the platform code. Really, it's like Motorola early platform code is like fucking unobtainium. I don't know why it's so hard to. All right, let's come back to that. It really doesn't feel like there's that much. All right, let me look at the platform code. Okay, hold on. Mock. Debug point, probe start. Okay, so some of that's driver code. Bunch of IPC stuff for compatibility, cache. I just had a horrid thought. I don't think the drivers were accessible on Motorola 68000. Okay, so we do have... Yeah, there was no... Everything was statically linked into the kernel. Okay, now I remember this. This is one of the big changes from x86 to Motorola 68000. Was that on i386, it was modular. On Next, it wasn't. It was statically linked in. And they shipped two versions of the kernel, ODMock, which was for optical disk, as if it was booting. That would have just been the cube, now that I think about it. I don't even think you could have easily upgraded the cube to OpenStat, but I guess it was supported. Yeah, release cursor. Let me look at chat. I'm not on Discord very much. I'm sorry, I'm getting a little late to chat. If you put it in the software channel, I'll take a look at it at some point. Let me take another look at something else before I call it. So Darwin 0.9 mock kernel. Yeah, because NeoZed and I really went through fucking hell to build this. Yeah, so kernel 1. Yeah, so this is Apple's thing. It's not what I'm looking for. Rhapsody kernel source. Because I remember doing all this with NeoZed ages and ages ago. Sorry that I'm not talking. I'm just trying to... I am really happy NeoZed went through all the flipping trouble of writing this all up. Okay, I guess this source CD has it. So this is what we built all those years ago. Well, that's downloading nice and slow. Alright, we'll let that go. Okay, this finished. So... All right, so why don't we just take this out for a test drive? So Arch M68K, cross compile M68 Linux GNU colon Mac def config. Not sure why that didn't get installed as... Okay, cool. That works. Alright. And I expect this just to build. And just for curiosity, I'm going to throw the VM Linux file at the NetBSD bootloader, and we're just going to see what happens. I'm assuming it'll either crash or hang, but... I just realized I'm on trunk, which I don't want to be. Well, I just want to see what it starts with. Yeah, so we'll let it boot. So we did learn quite a bit today. Like, this has definitely been like a successful sort of adventure. Um, I'm sorry for being silent. I'm just kind of mentally thinking right now. Probably will call it quits soon and do more classwork. Oh, the reason it's hard to find is because it was... That makes a lot of sense, actually. That makes way, way too much sense. Alright, that built... That built successfully. Oh, interesting. Did it not generate a Z image? I guess... I mean, we wouldn't be able to boot one with the next step, the NetBSD bootloader. Interesting. So let me read elf headers vmlex. Here. Entry point is 0200. Yeah, that probably won't work with next. Yeah, I'm gonna have to figure out how the memory map actually effing works, but at least in theory, this would be able to be booted. Yeah, it would be booted. I think I'm definitely gonna call this sooner rather than later. And Linux. Oh, someone... Void Shell, thank you for becoming a member. Yeah, it's like I said, it's just a lot of work to do, and I think I'm at my mental... How big is this kernel? Eight megabytes. Yeesh. That's more than half the system RAM. That is actually a really good argument for using an older kernel. Like, there's a lot of stuff you can turn off, but that is a chunky boy. Let's halt. Oh, right, because I didn't put it in the right directory. Just curious what this is actually going to do. I'm assuming it's going to just go kablam. Yeah, this is a really good argument on using the older kernel because it might actually be usable. Because this is going to suck if this is what I have to deal with the bootstrap time. Well, I can modify the bootloader. Yeah, oh, okay. That did basically what I expected to do. CPU go down in flames. Which we knew why, but yeah, that was kind of what I was expecting. I have really been convinced that to do this with the older Linux, a 2.6 kernel, maybe even older to be perfectly honest, like a 2.0 or 2.2 kernel would probably be the sweet spot of usability. 2.6 would probably... Etch was the Debian Etch was the last one that had a Motorola 68000 like release, but it was a very scuffed release. Sarge was the last one that like actually worked without any major caveats on it. It's been going good. I was able to isolate the bootloader into its own build system, so I have something I can fuck with when I need to do bare metal stuff. Yeah, it may have also just not finished loading. This is telling me, though, that a 7.8 megabyte kernel on a system that has 32 megabytes of RAM, to be generous, it's too bloated. Like, I just cannot see it working all that well. So I am really thinking 2.6 is the way to go here. Like, in that case, I could even go through, like, pull up that version of Debian and hack it in and have a full installer if I can get both the CD-ROM and the hard drive working. In theory, the only hardware I really need to, like, assume... The main things that I have to have drivers for is I have to have the RTC, which isn't terrible, the system timers, which I have code for, the SCSI chipset, which if Linux doesn't have a driver for it, I'd be surprised, but the driver might need some massaging. Serial ports would be nice, but not essential. If QEMU works, then we'll use that for like serial ports. Disable anything to see if it boots at all. It would take me a while to disable the everything. Let's see. Let's get into menu config. How much is the everything? Like, this is a pretty lean config. I mean, almost everything is built as modules. When I tried this on x86 a few years ago, the smallest kernel I could get was 2 megabytes, and I had to turn everything off. Alright, it's tiny config. Alright, well, let's see if that makes something smaller. I just saw it building Coldfire support, which I don't think I want. Because Coldfire would have been, let's see, your general platform. Yeah, because I don't want building for Coldfire. Classic, please. And, like, everything else is turned off. I can't even... The only things I can turn on is support for the pilot. Oh, because the MMU is disabled. Okay, that's a little bit better. Let's get 64 support, and we'll just build for Macintosh. Yeah, Coldfire kernel would have just completely fell over. Hey, Amiga of Rochester. Ooh. Okay, so that gave us a 1.2 megabyte kernel, so that is a lot smaller. So the question is, does it do anything different? Oh, that definitely did something different. All right, that time I think it got into the kernel and then shat itself, but that definitely loaded. Like, that legitimately loaded. We'd probably have to make some adjustments to the load address, which I have no idea how that's done, but we can figure that one out. I mean, it is a starting point. It's just like, yeah, I guess we can work with this. But tiny config is really limited. Like, I'm not even convinced we'd be able to boot up to a full user land with it. I'd have to turn on a fair number of stuff. And I don't even know how much that would be. It's something I have to think about. I do have to legitimately think about that one. Like, my gut feeling is saying do it with an older kernel, because if I want to run Debian, which I may or may not want to do, at least I'd have a matching userland. You can run old distributions on new kernels pretty easily, but My general experience with this has not been particularly good. All right, I think I'm going to call it here and leave it for more thinkings. So maybe I'll live stream later, maybe I won't. But yeah, I'm going to call it here. I'm 8 hours into this project.